So let's just talk about the bubble sort. So the bubble sort is a simple sorting algorithm. Here we compare two adjacent elements and then we swap them if they are in the wrong order. So suppose we have a list of numbers. Now here you can see all the numbers are in unsorted order. Now we can apply this bubble sorting algorithm to sort these numbers. So this is our bubble sorting algorithm. Now here in the algorithm we have two loops. We have this outer loop and this inner loop. Now the outer loop will run from 0 to n-1. Now the inner loop will run from 0 to n-1 I. So that means the inner loop will run. So in the first iteration it will run till the end. In the second iteration it will run 1 less. In the third iteration it will run 2 less. And this will be repeated until our array is sorted. Now for the optimization we are using this swapped flag which is initially false. Now in the inner loop if we perform any swap, in that case we are gonna make this swapped flag as true. Otherwise this will be false. So if there is no swap happened in any iteration of the inner loop, so in that case, so if the swap is false, that means our array is sorted. So in that case we do not need to repeat these loops again. We can just simply break out of the loop because our array will be already sorted. So let's just see how we can swap these elements in ascending order. So in the first pass, so because this is in ascending order, so we have to compare. If the first element is greater than the second one, then we're gonna swap these two elements. So this is our first pass. So here we're gonna compare these two adjacent elements. So if the first one is greater than second one, then we're gonna swap these two elements. So you can see the first one is not greater than the second one. So we are not going to swap them. Now we're gonna compare next two adjacent elements. So here 5 is greater than 1, so we need to swap these two elements. So that means 1 will go here and 5 will go here. These two elements will be swapped. And again we're going to compare next two adjacent elements. So here also you can see 5 is greater than 2, that means we need to swap them. 2 and 5 will be swapped. And again we're going to perform the comparison for next two elements. So here you can see 5 is not greater than 8, so we are not going to swap them. So this will be our array after the first pass. And you can see after the first pass, the last element will be at the correct position. Now we have to repeat this process. So in the second pass, the inner loop will run 1 less because the last element is at the correct position. So that means it will run from 3 to 5. So here also we're gonna perform the comparison for the adjacent elements. So here you can see 3 is greater than 1. So that means we need to swap these two elements. So 1 will go here and 3 will go here. And again we're going to perform the comparison for the next two adjacent elements. So here you can see 3 is greater than 2. So that means we need to swap them. So the 2 and the 3 will be swapped. So next we're going to compare these two adjacent elements. So here 3 is not greater than 5. So we are not going to swap them. So this will be our array after the second pass. And here you can see here two elements will be at the correct position. So this way we're gonna have the third pass. So in the third pass we have to repeat the same process. So here also we're gonna compare these two adjacent elements. So 1 is not greater than 2, so they will not be swapped. We're gonna compare next two adjacent elements. So here 2 is not greater than 3, so there will not be any swapping. So after this end of this loop, because no swapping happened, so the swap flag will be false. So because of this our loop will break. So when no swapping happened, we can say that the array is already sorted. And you can see here all the numbers are sorted. So because we are using this optimized swapped flag, we do not have to perform any more comparison. So we do not have to go through the pass 4 or 5 or anything. We can just stop our comparison right here. So in case of ascending order, we swap the elements when the first element is greater than second one. Now in case of the descending order, we perform the opposite. We swap them when the first one is less than the second one. So this is called bubble sort because you can see in the sorting process, in each pass, you can see the large item will be bubble up to the correct position. So here after each pass, you can see elements will gradually bubble up to their correct position. So this is just like the bubbles rising to the surface of the water, and that is why it is called the bubble sort. So here we have the function to perform the bubble sort, which takes the array and the size of the array. So we are using the nested loops, and we're gonna compare each adjacent elements, and then we're gonna swap them. And this is the function to print the array. Now inside the main method, so here we're gonna use the array. So the array will contain the values like 3, 5, 1, 2 and 8. So first of all, we're gonna print the unsorted array. So we're gonna print the array which has 5 elements. Now we're gonna apply the bubble sort to sort the array, and after we have done the sorting, we're gonna print the sorted array. So here we're gonna print the array after the sorting. So this is our unsorted array. After we have done the bubble sort, you can see all the elements are sorted. So hope you understand about the bubble sort. See you in the next one. Take care.